All right, 216 is 6 to the third power. 216 is 6. We're changing gears. We're in logs now. Soccer girls is the sorry, I don't mean to call you soccer girls all the time, but is soccer ladies, is the team still undefeated? Are you still?
Yeah, we're playing today.
You're playing today? I noticed you have your shirts on. I figured there must be a game or something, huh?
Yeah.
Who are you playing today?
No.
Taft? Okay. Are they good?
Yeah.
I don't know. Okay. Very exciting. They're ranked. What are you guys ranked in the nation now?
Right now, like 7 still, but I don't know if we moved up or not. Oh, we did? We moved up.
Okay. They're very good. Go out and watch them. Soccer's exciting. Over the weekend, we have soccer. My little 11-year-old daughter's playing serious soccer, and she was up in Dublin, and I get the little text from my wife, and they played this team, and they were in this tournament, and they tied this team, and then they went to the championship with the same team. 0-0, 0-0, 0-0 in the championship. Overtime, 0-0. Double overtime, 0-0. Penalty kicks, and they lost. And there were all kinds of tears pouring down. They offered them an icy. The hosting team says, "You guys played so well." And my daughter's like, "I want the icy." And she gets all fired up. Anyway, so funny. So serious. All right, anyway. 216 equals 6 to the third. So what they want us to do is change this into a log function. They want us to move this from exponential to logarithm. So how do we do that? It's another language. What we're going to do is we're going to take this statement, which is just a true thing, 6 to the third power. If you take your calculator, you could verify it. 6 times 6 times 6 is 216. So what? Well, now they want me to say the same truth in a different language. Like me saying one or uno. I'm saying the same number, two different languages. Here I'm saying a truth in exponential language, power language. Now they want me to say the truth in log talk. Well, how does that work? Here's what you do. I'm going to write it this way. When you gain or lose the log word. So when you put on or take off, either way it's the same thing, the word log, what happens? The base stays the base. The other two switch. That's my little mantra for how to change in and out. The base stays the base. The other two switch. Now, what do I mean by base? What are these called over here? These are called baseboards, right? Well, this is called what? The base, or I guess there's a legs, but we can also call it the base of the table. Base just means bottom, right? Base just means bottom is my point. Nothing more fancy than that. So when I say base stays base, I just mean, hey, and the base has something on it, right? That's why it's a base. So which one of these numbers is the base? Well, the 6, huh? That's the base. That's a base is something that has something on it. So that's the base. So when I say the base stays the base, I mean the base will continue to have something on him. So he'll continue the base. So you write log. I'm going to bring in a log word. And you know how logs work? You put a number low down, and that'll be the base. Like that. And now these guys, so the base will stay the base. The 6 is still lowered down. You purposely lower it down below the log word like that, indicating that it's a base. Right? The base is lowered down. So that's a base. That's lowered down. The base stays the base. And then the other two, the 3 and the 216, switch. So the 3, nope, that's not right. That's where it is normally. Right? The 6 is, normally the 3 is on the 6, so they switch. The 216 will go there, and the 3 goes to the other side of the equal sign. And that's it. I said that harder than it really is. It's really simple. Just the base stays the base. The other two just swap. That's all that happens. Instead of 6 to the 3, it's 6 to the 216. It sort of looks like 6 to the 216. It's meant to look that way. It's actually the inverse of that, but anyway, it's meant to look that way. That's correct. So that's all you do to change in or out. So this is a log statement now. We have a log word here. So we changed languages, one to uno. So we're saying the same truth, two different languages. Let's get you warmed up with the log talk. So 2.3 is 3 to the x. So that's an exponential. Now write a log statement. So try that. So bring in the word log. Base stays the base. the other two switch. Base stays the base, other two switch. So who's the base? It's the 3 and the other two switch. So the 2.3 and the x will trade spots. Instead of the 3 to the x, it's going to be 3 to the 2.3, and the x will go over there. Good? And that's it. That's all. Right now, we're just warming up. We're just, how do you change languages? Just like that. Base stays the base, other two switch. Nothing more complex than that. We haven't solved anything yet. We're just saying the same truth in another language. Good? Okay, try that. So now we're in the log language. Now we're saying uno, and we want to go back to 1. Now we want to say it in normal or exponential. So now we want to change back to, we want to get rid of the log word, in other words. Right? So here it's in the log language. Go to regular. Go to no log. What happens? Same exact thing. When you gain or lose, either way, gain the log word, lose the log word, either way, same thing. What happens? Base stays the base, other two switch. Who's the base? Well, the 9. He stays low down. He's going to have something on him still. The other two switch. Instead of 9 to the 81, it's 9 to the 2, and the 81 goes over there. Which is, of course, what we already know. We're like, yeah, we know that. 9 squared is 81. Well, the log said, that's what I was saying. That's what I was saying in my language. See how it works? They're saying the same thing in two different languages. Like that. Good. So log base 3, 81 is x. Try that one. So translate out of the log language. Cross off the log word. Remove the log word. Base stays the base, other two switch. Lose the log. Base stays the base, other two switch. Instead of 3 to the 81, it's made to look like powers. That's why logs have numbered lower down. They're reminding you, hey, I'm like a power thing. Really, they're inverse power things, which we'll see tons of on Thursday. Logs are inverse exponentials. That's what they are. We're going to graph them both and see them on graphs. But anyway, it's made to look like powers to make you think of powers. Instead of 3 to the 81, it's 3 to the x, and the 81 goes over there. Does that make sense? Yeah, you could solve it, but they're not making us solve it. The answer would be 4. But they're not making us solve it. They're just saying that's good for now. Change the language.